Once we have loaded an empty template file, we're ready to begin collecting data. Ensure that the apparatus has been turned on at least 30 minutes to allow the gas sensors to stabilize. Next, switch on the sample pump and ensure that the sample flow rate is 300 mils per minute as indicated by the rotometer. If not, adjust the pump speed on the front of the S147 box. Next, configure the subject for the experiment. In other words, install the heart rate monitor, ensuring that the receiver is within 1 meter of the transmitter. Put on the face mask, etc. Now I'm going to actually collect some breath data from myself, so I'll switch over to the empty template. The data will stream into the table. You'll see this as I collect data, and also be plotted on the graph. The digital meters will change their values depending upon the output of the sensors. To begin collection, just hit the Collect tab and we can begin collecting data. When enough data has been collected, you can stop the collection manually by hitting the Stop tab. Alternatively, there's a hotkey beside the Collect tab which allows you to control the data collection. You can change the length of the experiment, the sampling rate, and so forth. This will be very useful if you're using the system as an independent data logger for other experiments. Now, as the data was being collected, you saw the raw data stream into the table at 50 Hertz. In other words, each of the 4 sensors are sampled every 20 milliseconds. This raw data is then used by the calculation columns, and I've probably set up 40 to 50 different calculations to provide the breath data useful to the user. Now I'd like to discuss the time plot. This is a very useful diagnostic plot for ensuring that the system is working properly. Once you get familiar with the levels, you will know if the sensors are working properly from the values that you see on this plot. So there are 3 profiles on here. The top profile in blue is that of oxygen, going from about 21%, that value in air, upon an inhale, down to about 15% during an exhale. The bottom profile in purple is that of carbon dioxide, and you'll notice it's out of phase with the oxygen. When oxygen is low, carbon dioxide is obviously high during an exhale. During an inhale, the carbon dioxide value is nearly 0%, the background carbon dioxide level in air, and going up to about 5% during exhale. The black profile is the breath flow. Positive flows indicating exhale, negative flows indicating inhale. The colored dots indicate the times at which the program selected the breaths, with the orange dot indicating the beginning of an exhale, detected as a zero crossing of the flow. The green dot indicating the end of the dead volume. This is the volume in the airway and the mask that has to be cleared of the previous inhale before carbon dioxide starts coming out from deep within the lung. The red dots indicate the end of exhale, again by a zero crossing. Data is used and calculated per breath, and the breath is determined as the time from the end of one exhale to the end of another. Breath parameters are calculated at the end of each exhale and printed out on the following breath plots in the following pages. I'll talk about this more in a moment. So we now have seen how the breath data is collected.